Altering the school system is like saying you want to control the rainfall. Both of them are near impossible, but we can use tools to manage both. My goal is that by the end of this presentation, each of you have an understanding of natural language processing, how it works, and some of the complex infrastructure that we're using to create these models, and you guys have some ideas about the use cases in education. When someone asks you about the current state of your education, you probably think about how you can't remember anything from your seventh grade science course, or the unpersonalized structure that lowers the intellectual value to the average students, or the system's inability to track long-term data from your kindergarten years up to your last year in high school, monitoring how you're growing as a student. Just a quick raise of hands for all of you that have your cameras on. How many of you would prefer oral assessments over multiple choice assessments? And how many of you would prefer a system that adapted and was personalized for all of your learning versus just meeting the needs of the students in the class? How many of you guys would like to have an understanding of how you were intellectually as a kindergarten student to now how you're intellectually as a 12th grader and even beyond, really transforming what the idea of lifelong learning looks like? Artificial intelligence is one of the ways that we can solve these problems. But I'm most interested in the problem of retention. Throughout high school, I spent 4,000 hours in courses like history, science, and math, but I forgot 95% of what I learned. It's like working in TKS and your director's only showing up for 3 days out of the entire year. Some sessions they're there, some sessions they're not. So how does this work? Well, for all of you innovates, you guys have an upcoming BCI session this weekend. So let's say you're preparing, and before Saturday hits, each of you guys have to record a quick 5-minute Loom video explaining the BCI technology, how the technology works, and then give some insights on how you might use it. So what those use cases are for you personally. You then upload it to a software that processes this text. We then create a transcript and a summary, and then we give you a score based on your comprehension, your mastery, etc. And you can just continue to repeat this loop over and over until you get the score that you want. And in order to give you a score, we use a process called supervised learning to train a model on what a good explanation of BCIs is. The first step is through a training data set. And so what this means in a training set is we're attempting to just formulate what the end outcome looks like. So we'll feed the model. Here's what a ton of good summaries about BCIs look like. And the entire idea here is the more models that it sees that are great, it will then be able to recognize the distinction between what's a great model or what's a great piece of text that you're giving it, and then what's a poor piece of text. So that's the overall idea of what goal assessment is. What we want to do is we want to be able to have each of you discuss in some form of summary what you know about BCIs, give insight about the technology. So we're just training the data set again on everything on what good looks like. The second part of the training data set is something called validation data. And this is the preface to testing data. Validation data gives each of the models what a first look is of unseen data. That way I can start to make better predictions on the data. And then lastly, on the right, we have testing data. Testing data is the last part where you can start to see what the data points are, how accurate the model is. And then based on the accuracy of the model, if it's 30 to 40%, we would obviously continue to train it more and more until we would raise the accuracy. The goal being 90 to 95%, as perfect as we can get it. That way the model can give you the best feedback possible. So now that we've crossed off the first part, getting the model to actually understand what good looks like and provide you with summaries and scores, now we need to actually get the computer to understand what you're saying. So in order to complete this, we use a process called self-attention. TLDR on self-attention is we're modeling natural language understanding to draw dependencies between the inputs and then the outputs of data. So what is natural language understanding? Well, NLU is a process where we're using computer software to really just understand what the input is. The computer is understanding these complex sentences, these texts, these dependency aspects of each one of them to understand how these words relate to each other. So think about when you're listening to a new sentence, you might be using context clues right now to understand how each of these words that I'm saying measure up with each other. And the process for NLU is actually very complex for computers because there are so many different forms of ambiguity, and we're still training these computers on what it looks like. First part is something called lexical ambiguity. So in this sentence, he is looking for a match. The computer doesn't know and has very difficulty just understanding which is correct. Is he looking for a partner, as in someone to go on a date with? Is he looking for a cricket or football match? Is he looking for a match to potentially light a candle? So we have to teach the computer what it means in this context. Computer also has some struggles understanding structural ambiguity. This is where the computer makes mistakes around the grammar. In this sentence, the chicken is ready to eat. Is the chicken going to eat the food, or is someone going to eat the chicken? So the computer doesn't know what the distinction here is either. And then another popular one here is referential ambiguity. And this is where computers encounter pronouns and they don't know how we're referring to each other word in the sentence. So each of us encounter some of these problems in our own lives, but our mental algorithms are much more developed, much more intuitive, and we just have so much more data from the time that we're 0 to now 18 that we can develop context clues and then decipher what these words are and develop an opinion on whether or not they're related. So in order to remove the ambiguity from computers, we just need to use the exact same process. And what self-attention allows us to do is quantify connections between different words and create strong associations. And so we just show that to the computer several times, and then it starts to understand the associations between these words. So with the self-attention, the math part, and everything in terms of what it looks like on the back end, we're passing words through something called an embedding layer. And we're converting all of these word inputs, the hi, how are you? We're converting all of these into numbers because the computer and machine learning can only deal with numbers. And then from the word embeddings, as you'll see, x1, x2, x3, x4, these are called vectors. And these vectors have 4 different words. And all of these vectors are exclusive of each other. So they have no idea what each of the other words here are. And in order to calculate the decimal value of these vectors, we use a matrix called W star. And you'll see this diagram on the right. The main properties of this is most of these values are not normalized. So you can see here, we have some that are 0.5, 0.87, 0.81, or 0.877. We want computers to just read each line horizontally and get the number 1. That's what computers like. Computers like the numbers 1. But right now, if you add all of these up, you'll get a number greater than 1. So we need to do something called normalizing the values, which is we will take each of these values, and it might be a formula like a divided by a plus b, which is you take 0.1 and the b value is 0.87. So you would take 0.1 divided by 0.1 plus 0.87. And you would do that repetitively until you were able to normalize all of the values and get them to 1. And then after we get a normalization and we stack each of these inputs, we're then able to do something called transposition. And after that, we'll then be able to create something called just this y, and this is the new data. So this is the output of the W diagram with all of the normalized values, the X transposed, where now we get Y, which is the ability to have context clues and actually understand what each of the data means. And after this process, as you can see in this diagram, with self-attention, the words are much closer together. There are higher correlation rates because we've gone through this process of teaching the model what context clues are and how to really understand each of the texts. Before self-attention, the computer knew that there might be some correlation to the words, but it wasn't as strong. And so we just continue applying this model several times until we can understand most of the words. And after the computer understands all the words, we can then use NLP to then compare similarities in the text. So we'll use a 0 to 1 scale, where 0 means that these words are profoundly different. So the computer has no idea that these words are similar, and then 1 meaning that they're the same. So post receiving this output score with your Loom video that you were talking about BCIs, you would then be able to get this feedback on a 0 to 1 scale and then continue to train over and over again until you were able to hit 1. And the end result of all of those ideas is just you're able to strengthen your connection between BCIs, able to understand everything in terms of how you're able to explain it to other people. So it's a really, really good technique in terms of just how you can take this knowledge and then start to apply it to the session. But some other NLP ideas, really, really interesting what this technology is able to do. So we can use NLP chatbot technology for literacy acquisition, where we can interpret what students are saying and then provide them either a text or audio response. We can use text summarization for research papers and allow researchers to, as opposed to spending hours and hours reading 20, 30-page papers, we could summarize them and then provide that to different people. We could use NLP for ADHD student communication training. One of the biggest problems that ADHD students have right now is that they don't have enough training to actually go out and talk to other students without ADHD, whatever the brain disorder that they have. And so we could use NLP just to give them that practice before they got into the real world. We can even monitor student motivation through sentiment analysis based on what students are giving their teachers in text feedback. We can then use sentiment analysis to analyze what the polarity of what they're saying is, what the severity is, etc. And then we could even get to a level potentially where now you can have conversations with your computer, and Google can understand exactly what you're saying and then give you a response. So it's Siri just on Google while you might be reading something. These are just some ideas that have been interesting to me. I've been exploring NLP for the past 2 weeks now, really, really deeply. And these are some of the applications that I'm thinking about just as I continue. But the prerequisite to getting more of these ideas that are higher complexity and also higher impact is just spending some time learning more about transformer models, the BERT framework, dissecting more about bidirectional LSTMs and really understanding how they help with natural language understanding and then even natural language generation, and then understanding and thinking about the code logic and how this really applies in a more applied setting. The goal is to leverage all of these technologies to really help students unlock their potential. The best way that I think to enable an interesting feature is to use a current technology like artificial intelligence. The education system isn't a problem. It's the misaligned incentives between what school wants and what students want. Schools equal grades and metrics because they need that for funding. Students, they want fun experiences that allow them to be curious. But through an application like oral assessments, we can meet both needs. We can help students learn, we can help students have fun, and create better long-term solutions for learning. Thank you.